Welcome to NOAA Live. My name is Catherine Longmire, and I'm going to be moderating today's webinar. This series is sponsored by NOAA's Office of Education, along with the National Sea Grant College Program, where I work, and is supported by Woods Hole Sea Grant and NOAA's Regional Collaboration Network. All of our speakers work for some part of NOAA, that's NOAA, or the National Oceanic and Atmospheric Administration. Today, we are introducing to you Sean Waugh with NOAA's National Severe Storms Laboratory in Norman, Oklahoma. Sean will be talking about hurricanes, and if you've been following our series, you might recognize him. He was on NOAA Live last year talking about tornadoes, and he was so popular that we asked him to come back. And while we've covered hurricanes in previous talks, we focused on storms that stay out over the ocean. In this talk, Sean's going to fill us in on what happens when a hurricane moves on to land. Before we start, we would like to recognize that we are all coming to you from the traditional lands of Native communities who have substantial traditional knowledge to share with us. We acknowledge that Sean is coming to us from the land of the Creek and Seminole peoples. We are hosting this webinar from the ancestral lands of the Pamunkey and Chickahominy tribes. And I also want to extend a special thank you to our American Sign Language interpreters, Lauren Harris and Bobby Quinn. So a few guidelines before I hand you over to Sean. You are all muted. However, there is a question box where you can write questions, and we encourage you to do that as we go along. If we don't get to your question, no worries. We will give you some resources so you can look things up after the webinar. Also, Sean has generously agreed to answer questions, so if we don't get to your question, we will post the answers along with the recording of today's webinar on our website. Sean is also going to have some questions for you throughout the webinar, so get ready to type. All right, I am set, so I'll turn it over to Sean. Please take it away.
Awesome. Well, thank you guys for having me back. I've really enjoyed watching the NOAA Live series and being a part of that. And like it was mentioned, today we're going to kind of change focus from some of my previous talks, and we're going to actually talk about hurricanes and what it means to take observations on the ground when they make landfall and in the eye and in all the conditions that kind of surround hurricanes. Now, who am I? You know, I'm just this random guy on the computer screen that's going to be talking to you about weather observations today. So a little bit of background about myself. I was actually born and raised in South Central Kansas. I really didn't go too far. I've only moved about 3 hours away from where I originally grew up. So basically my life hasn't really changed a whole lot, but weather has been one of those things that I've basically been interested in, and I've wanted to be a weatherman my entire life. My earliest memory was actually on my grandfather's farm up in North Central Kansas. He grew a lot of crops, and one of those was wheat. And I very distinctly remember one night he was actually pacing in the living room, and he was very concerned because the weatherman on TV was talking about a hailstorm that was nearby, and he was worried about his crops. And thankfully, it ended up not happening, so there was no damage to his crops. But he was very upset, and he's very angry at the weatherman on TV and said, you know, they're always wrong, and I don't know why I listened to them and that sort of thing. And I stood up, and I think I was like 4 years old, and I was like, Grandpa, I'm going to grow up someday, and I'm going to be a weatherman, and I'm going to be right all the time. And he said, well, you're going to make a lot of money because you're going to be the only one. And it's just stuck with me. I've never really deviated off of that. I've always had a passion for studying the weather and trying to understand things. So this has been something that I've been kind of chasing and working towards my entire life. And I moved to Norman, Oklahoma, which is where the University of Oklahoma is, in 2005 to start college. And I actually spent about 11 years in college getting 3 separate degrees in meteorology to kind of give me that background and that understanding of the weather that I had such a passion for. And it's really given me all the tools that I need to do the research that we do and to have, you know, the ability to have this talk with you guys today. And it's something that I'm really, really excited about sharing. And when I graduated in 2016, I actually started working for NOAA's National Severe Storms Laboratory, which is where I'm at right now. I'm coming to you live from, you know, NOAA's own building here. So this is something that I've really got a lot of passion for, and I'm excited to talk to you guys about it. So if you're familiar at all with NOAA or with some of the different line agencies, or maybe even you know what the National Severe Storms Laboratory is, you know, when you think of severe weather, you think of things like tornadoes, lightning, hail, flash floods, like, you know, those types of severe weather events. But this talk is about hurricanes. You know, why does NOAA's National Severe Storms Laboratory want to talk about hurricanes? And the answer is that a lot of those hazards are actually present in hurricanes. And it's not something that a lot of people focus on all the time, but hurricanes can definitely produce lightning, and they can certainly have hail in some rare cases. They produce tons of flash flooding, and they can actually have tornadoes. So we need to understand those systems as they make landfall and as they produce all of these hazards so that we can better help protect the public, which is our main goal with all of this. So if you're not familiar at all with a hurricane, maybe you don't live near the coastline, or a hurricane's not something you've ever really had to worry about, there's actually a really good overview talk in a previous NOAA live session. It's webinar 19, and they talked about getting prepared for hurricane season and some of that. But just to give you a little bit of background on hurricanes, hurricanes are extremely powerful storms, and it's basically a collection of a lot of storms that are all rotating around a center point. And those storms are fueled by the warm water of the ocean. As that warm water evaporates, it actually provides fuel for the storm to work. The warmer the water is, the stronger the hurricane can become. And that's why we see that very rapid and sometimes drastic change when hurricanes make landfall, is because they lose access to that water source. They lose access to the fuel that's kind of driving them. And if you've never seen a hurricane before, or maybe you just haven't really studied them that much, you may not know what all the parts are. But for those of you that do, here's your first question. There are three main parts that I want to mention real quick. The first one is the eye. Can anybody tell me where the eye of the hurricane would be? And I'll give you a few seconds to type those answers into the chat box.
Okay, everyone, let's get some answers. All right, you got in the center. Jasper says in the middle. We've got another vote for center of the storm.
Right, so it seems like you guys are on the right track, right? Like a few of you have said center, and that is actually right. It's that kind of clear donut hole looking thing right in the middle. And eyes are very interesting inside hurricanes because they're actually pretty calm. There's not a lot of wind. Sometimes if you go outside, you can see birds flying around. It looks like a nice day outside. But right next to the eye is the other part that we're going to talk about, the eye wall. Now, this is probably giving it away, but does anybody know where the eye wall would be located?
All right, where's the eye wall? On the west side? Next to the eye, around the eye. Oh, right. I think you're getting around the eye or surrounding the eye.
Those are on the right track. So the eye wall is that really, really intense part that's basically right next to the eye. And that's where we see the strongest winds. So you go from this really, really intense area of winds and rain, and then you go to the calm, clear center in the eye. So it can be very unnerving if you've ever experienced one of those types of events before. And then there's another part of the hurricane that we're going to mention, and that are the rain bands. There's the eye wall that we were talking about, but can you guys tell me where the rain bands might be? Does anybody know where those are?
All right. Type. Laura says the outer edges of the storm. Paul says around the eye. Jasper says on the outside. Liam says another around the eye wall.
Those are all really good answers, and you guys are all correct. The rain bands are those kind of spiral features that you see that kind of fan out away from the center of the hurricane, and these are where things get a little intense for really short periods of time. There's really strong thunderstorms in there, things that you might experience on a non-hurricane type day, but they're all kind of spinning and rotating around that center point, and that's why we call those the rain bands. Now, you might be wondering, how do we study something like this? I mean, this is this big storm and it spends most of its time out over the open ocean. How do we even observe something like this? And when it's over the ocean, that's where the NOAA hurricane hunters come in. So NOAA men and women actually fly planes into these types of storms, and they take observations that directly help us figure out where that storm is going to go and how strong it might be. And there are even sail drones that are being used right now, and these are basically automated boats, and you may have seen that on like social media recently. There was one that just went into Hurricane Sam out in the Atlantic Ocean, and it has some really incredible footage of what it looks like to be on a boat inside the main part of a hurricane. So we've got a lot of tools and observations that can kind of help us determine the conditions that are feeding these types of things when they're out over the open ocean, and that helps us figure out where it's eventually going to go. Now, when do hurricanes actually form? You know, is this something we have to worry about year round? Well, there is actually a season for hurricanes, just like there is for tornadoes. And the peak of that season is about September 10th, so it was a few weeks ago, but it spans all the way from June 1st to November 30th, at least for the United States. So you can see from that graph, and that kind of gives you an idea of when storms have occurred, that it's something we have to worry about almost all the way around throughout the year. So it's something that we always need to kind of be aware of and be paying attention for. But that peak season is really when the conditions are best for hurricanes to form, right? And some of those storms form close to us, you know, maybe right off the coast. Some of them can form as far away as Africa, and they got to go all the way across the ocean before they, you know, even start to impact the United States. So we have to pay attention to those for a really, really long time in some cases. And that's what NOAA's National Hurricane Center does. At least for the United States, they do a lot of the forecasting and intensity track information to try to figure out where that storm's going to go. Is it going to impact the United States? You know, how strong is it going to be? All of that. And they do a fantastic job at it. And it's a big job. But we're also not the only people that have hurricanes. There are hurricanes and tropical storms all over the planet. I mean, East Africa, Australia, China, Japan, all of these places have hurricanes. And that map down there in the bottom left shows tracks. Those are all individual storms. And there's a lot of them out there. I mean, even Hawaii's had, I know we got somebody on here from Hawaii. Hawaii has had, you know, storms like this affect them. So it's something that a lot of people can relate to and have to worry about when those types of things come. So what are the hazards in a hurricane? You know, what do I need to worry about if this is something that I gotta prepare for and experience? And hurricanes are actually rated by their sustained maximum wind. How high is that wind blowing and how hard is it blowing for a certain period of time, right? And that's about a minute near the ground. Now, gusts can be much, much higher. You know, you can have something very short be a lot stronger than that, but this gives us a way to kind of categorize hurricanes. And those categories go from 1 all the way up to 5. Now, when you hear about category 3, category 4, category 5, those are what we consider major hurricanes. They are extremely damaging, and it's something that you really, really need to take preparations for and be prepared for, because they can cause a lot of damage. And I mentioned earlier when we were talking about the parts that the winds are going to be strongest in the eye wall. So that's where you're going to see a lot of these really high-end winds. But that's not the only hazard. That's what most people focus on. But there are a lot of other things that hurricanes can produce, and that's things like storm surge, where the hurricane actually drags water on shore with it, or inland flooding. It rains so much, you know, sometimes it's 10s or 20, you know, inches at a time, and it can just cause massive flooding. Or tornadoes in the outer rain bands especially. Like, these are all things that can be very significant if they affect you. And these are the things that we're trying to study and understand. You know, what's causing these and why is it causing them there and not over here? We have to understand all of these hazards to be prepared for them, not just the strong winds. So hurricanes have tornadoes? That seems kind of weird, right? Like, that's not something you really hear about too often. And it turns out they do. Not all hurricanes produce tornadoes, but some of them can produce a lot. Hurricane Harvey, as an example, in 2017 had 52 tornadoes. And NOAA's National Weather Service had to issue 326 tornado warnings across 7 days related to that hurricane. And some of those were as far away as North Carolina. So a hurricane can actually produce these hazards for a very extended period of time from a very far distance away from where the hurricane actually makes landfall. Hurricane Harvey made landfall in South Central Texas, and people in North Carolina had to worry about it a couple of days later. So it's definitely something that you can't just pay attention to if you live right along the coast. Like, a lot of us have to pay attention to these kinds of things. So how do we actually study something like this? And before we go into that, I do want to pause just for 1 second, because I know we've covered a lot of information. Does anybody have any like really burning questions right now? And I'll take maybe 1 or 2 before we keep going. Anything related to like how hurricanes form or when they form, that sort of thing.
Yeah, well, we do have one good question, which is, Nancy asked, if you are not good at math, can you still be a meteorologist?
Yes, meteorologists cover a wide range of things. And I went to school with a lot of different people, and some were great at math and some weren't that great at math. And there are a lot of different aspects to the field of meteorology, and there are a lot of different people that are working on different things. So if you're passionate about the weather and being a meteorologist is something that's really interesting to you, absolutely go for it. It's things that you can study and you can work on, but don't take, being a little like not as good in one sort of area of school as a deterrent. Don't let that kind of thing stop you. You can definitely do it.
That is so good to hear. And we'll do one more question. Miles asked, can hurricanes flood uphill areas?
Can hurricanes flood uphill areas? That is a really good question. Terrain, which is what you're talking about, has a very big impact on where that water sits. And a lot of people think that if they're on a higher ground, it's going to take more water before they can get flooded. But I've actually seen small areas on top of hills get flooded. So just because you're higher up doesn't necessarily mean that you don't have to worry about it. And you also have to consider when that water is flowing down the side of the hill, for example, you have to consider things like mudslides and erosion and things like that. So there are a lot of different hazards that can occur even if you're not on like a really flat, low-lying area. So yeah, I think you definitely have to pay attention to it. Okay, so
yeah,
now that we've talked about hurricanes a little bit, let's talk about how we study them and some of the tools that we use. And that's with observations. So we've got surface observations that we take, things like temperature and pressure and wind speed and wind direction. We've got upper air observations like weather balloons. We even use radar. And most of you have probably seen a radar image on your phone because you can get it on almost any phone or tablet or computer that you have nowadays. And our goal with all of these is to try to determine the conditions that are driving the storm. What's fueling it? This means we have to drive into the hurricane to collect these observations. And that's an area that some people are being told to leave. So we have to do this really, really safely to make sure that we're being safe while we're collecting this data. And we have to use this information from a variety of sources and locations so that we can really understand kind of what's going on and what's feeding these types of systems. And the first vehicle that we use is actually called a mobile Mesonet, which is essentially a mobile weather station. And if you aren't familiar with this, there's actually a really great talk on mobile Mesonets that was also a NOAA Live webinar, which I did about a year ago at this point, actually, where we talked about using these to study tornadoes. And they're very, very useful vehicles. They've got a platform essentially that measures things like temperature, relative humidity. And if you don't know what relative humidity is, because it's kind of a weird concept, it's basically how much water vapor is in the air. It gives us an idea of how much rainfall potential there could be. That relative humidity is what's driving the storm in this case. Things like wind speed and wind direction or pressure. And we have all of this on a truck that we can drive around. It's really heavy and it's got a lot of power and storage capacity. So it's really, really useful for doing these sorts of things. And this gives us all the information that's going on inside those storms to let us know what's feeding them. Fun fact about these, we have to build all of these by hand. There's no storm chaser package that comes from a car manufacturer that we can just order. So a lot of the equipment that I'm going to talk about today, we've actually had to design and put together ourselves. This is a really big part of the challenge of doing this type of work, is creating instruments that can make these observations and survive. And that's one of the things that I love so much about my job. Now, I mentioned a couple of different variables, and surface winds are probably what most people can identify with, right? Like everybody knows what it means to be windy outside. And if you live in Oklahoma like me, you really know what it means to be windy outside, because it seems like it's always windy here. But those observations actually help us determine where those winds are occurring. How strong are they? How bad are they? How long do they last? That sort of thing. Now, I want to ask you guys a question. What's the highest wind speed that you've experienced? Is it 30 miles an hour, where you've got, like a light breeze, the wind's kind of ruffling the trees, or 50 miles an hour where you start having like tree damage, or 70 miles an hour where it starts uprooting trees or knocking over small buildings, or 100 miles an hour? And gosh, I hope nobody's experienced 100 miles an hour, but that can actually rip roofs off like you see in that graphic there. So what do you guys think? What's the highest wind speed you think you've experienced?
All right. Frederica says 60 miles per hour, and Michael says 70. Alice and Paul say 85 in a thunderstorm. Holy smokes. We've got some 60s. And you know what? It's funny you asked this, because we actually got a question earlier. What was the fastest hurricane growth that you tracked? Liam had asked this.
So we'll come back to that question in a minute. I'll answer that in just a few seconds. So it sounds like some of you guys have experienced.
I want to say, one second. Jasper said we just got a big storm where winds got to 90s. That's cool.
90, wow, that's really, really high. And I've definitely had some thunderstorms like that that have had some really, really high winds. So I'm going to show you a video from Hurricane Laura, and this was what 80-mile-an-hour wind sounds like. And unfortunately, our audio's not working because the sound in this is just phenomenal. It's so, so loud. I mean, you have to like turn your speakers down. It's so loud. But as you look out the front window of the truck, you can see the rain just screaming by the front of the truck. And this is basically constant. In a thunderstorm, you can have short bursts like that happen, but in a hurricane, it's there all the time, at least as you get closer to the inner part of that hurricane. So that's one of the reasons why it can be so damaging, is because it's there for an extended period of time. And one of the things that we're doing with this information about figuring out where these are is we can actually use that to help design buildings that can withstand those types of impacts. We want to build stronger buildings so that we don't have damage from them down the road. So that's one of the goals of our research. Now, we've talked about surface observations, but that's only one piece, right? Like, we're just this little tiny dot on the bottom of our planet, and there's a lot of information above us that we really don't know if we're just collecting that surface data. So to do that, we actually have things called radiosondes, and I have one here. This is what a radiosonde looks like. It's relatively small. It's very lightweight. It only weighs like a quarter of a pound, maybe. I mean, I've had coffee cups that weigh more than this thing, but it measures the same things. There's actually a little wire right there on the front that measures temperature, and there's a sensor that measures relative humidity, and then we can track its motion and figure out how strong the winds were, and it's got a pressure sensor on the inside. So this little device gives us all of that information, but vertically throughout the entire atmosphere, which is really, really useful. And we actually launch those directly out of the back of the vehicle. We carry helium tanks with us to do that. So we go out into the storm and we can launch these types of instruments and get vertical data as well. Now, this gives us the ability to target specific locations, but you can imagine launching a weather balloon inside a hurricane is probably not easy, and you'd be right. These balloons are about 4 or so feet in diameter, so they're pretty big, and trying to hold on to that when the winds are at 30 or 40 or 50 or 80 miles an hour is really, really difficult. And when we launch them, you can see in the video, they really don't go up so much as they go sideways right off the bat. So figuring out ways that we can do this and actually launch this type of instrumentation into these storms has been a really big challenge. And it's one of the reasons why we don't have a lot of these observations. So this is part of the reason why we go out and we do these sorts of things. But what kind of information does that give us? You know, as that weather balloon goes up, one of the things that it calculates is something called precipitable water. Basically, how much water is there in the air? If you took all of that water vapor that I talked about earlier and condensed it down, how much liquid water would that be if you melted all the snow and everything? And when we did this in Hurricane Harvey, we actually found that there was a record. It was 3.26 inches, which if you have a hard time visualizing what 3.26 inches is, this is a ruler. That's like half my face. That's a lot of water on just that tiny little profile. And if you expand that out over the entire hurricane, that helps us get an idea of why it might just rain a little bit in some places, but other places we have these massive flooding events that can be really damaging and life-threatening. So that's one of the reasons why we launch these balloons, is to try to figure out that information. It also helps us understand how much shear there is in the atmosphere. We talked about that in our previous webinar, where you have changes in wind speed or wind direction with height and how that affects the environment to produce tornadoes. And that's something that we're still studying with weather balloons as well. So these are really, really useful, and they help us try to understand where and when these hazards are going to occur. Now, we did talk about driving a lot of equipment into hurricanes. So before we talk about how to do that safely, I did want to pause and see if anybody's got any questions about the instruments we use.
Let's see. Not necessarily about well, actually, we have one question. Do you study on boats?
On boats? I don't study on boats. NOAA does, though, because we mentioned that sail drone earlier that's actually out in the hurricane collecting these types of observations out over the open ocean. So there are ways that we can get that information out on boats. I definitely wouldn't want to be personally on a boat in a hurricane, though. That's not something on my list. But that's a good question.
Yeah. And then I wanted to ask another one. So I wanted to ask another question. What are the materials on the trucks that you're using to track these storms?
Like the equipment that we use?
No, like, can the trucks that you drive into the storms, can they withstand the
Gotcha.
storm?
So we're going to talk about the safety of doing these observations here in a little bit, but those trucks actually have, if you noticed, a hail cage around it because we use it for severe weather. But that also helps protect the truck if we were to get into an event that had like debris, like a tree limb or something like that. And the truck's pretty hardy. I mean, they're built to withstand quite a bit of, towing and hauling things around, and we use them a little bit different way, but they're built to withstand those kinds of things. But we do take very, very like long considerations about where we're actually observing these. And that's what I'm going to talk about right now. Safety is our top priority. There are no exceptions to that. No data is worth risking our lives or our equipment or anybody else's safety just trying to collect. And the biggest threats to that are wind and the debris that comes along with that, and then flooding. So what I'm going to do is I'm going to ask you guys, I'm going to give you a couple of examples, and I want you to tell me if you think this site is a good site or a bad site, like this one. This one seems pretty open. There doesn't really seem like there's a lot of stuff around that might, hit you or blow into the car or things like that. There's a little bit of water nearby, but do you guys think this is a good site to try to operate off of? What do you think?
We're having, no.
No.
Theodore is really bad.
Really, really bad. That would be right, because that's a lot of water already nearby, and when you add more to it, that roadway can flood really, really easily. That video there was actually an underpass on a highway. It was under about 20 feet of water by that point. So being on a road where you can flood very easily is definitely not where we want to be. So, all right, well, what about this one? There's no water nearby, so we don't have to worry about flooding. And, does this seem like a good site to you guys? You think this would be a good place to operate?
What do you guys think? Too many trees.
Too many trees.
Yeah, a lot of people are saying too many trees. Paul says too many trees. Theodore says really bad as well. Miles says nope.
Yep, you guys are all right. Trees are bad. I mean, I like looking at trees and I like trees in my front yard, but I don't like trees when it's really, really windy because that can actually cause a lot of debris. And if that blows into the car, now we've got a problem, right? So we don't want to put ourselves at risk, and it may not flood, but that tree damage could be a really, really big problem. All right, so what about this one? This one's in town. We've got some good structures nearby, maybe some places to eat. This seems like a good place, right? Like, it's not out in the open like the other two were. Is this a good place? Like, should we operate here?
What do you guys think? Let's see. No. No. Let's see. Mark says there are buildings. Laura says no. Michelle says no.
Man, you guys are on the ball today.
Yeah.
No is right. There's a lot of damage that can occur inside towns like this, especially as the wind gets really high and that storm surge comes in, or you have flooding, and we don't want to be anywhere near that. On top of that, we don't want to cause problems for anybody else that's there. There are a lot of emergency personnel that are there that have their own jobs to do, and we don't need to add to that at all just trying to do this work. So we don't want to be there either. So, all right, fine. What about this one? And I'm probably giving it away considering I'm already standing there, but what do you think about this one? Does this one seem like a good site?
Yes. Oh, wow. Let's see. Liam says yes. Alice and Paul say yes. Theodore says definitely. Michelle says yes.
Man, you guys can't be critical.
Yeah.
You're right. So
I see power lines.
That is a good one. And the power lines are a good observation. It's open. There's probably not a good risk of flooding because it's kind of elevated, and there are trees, but they're pretty far away. But those power lines could be a problem. So what you can't tell from that is those power lines are on the downwind side of where the wind was going to be coming from. I mean, it's a hurricane, so we kind of know where the wind's going to be. So if they were going to come down, we wouldn't have been in danger for where that would have happened. And it's behind the road quite a ways. They're pretty high up, so the perspective is a little different. But that's a really good observation, and that's something that we have to watch out for because power lines go down very, very quickly in a lot of these cases, and that can be a really big problem, especially for our truck that's really tall. Now, when we talk about deploying safety and putting our observations out there and kind of setting them up, this is something that we have to critically evaluate, and we do it constantly. We are always looking at storm surge maps and terrain maps, trying to figure out how much water there's going to be and where it's going to go. What sort of debris damage do we think is going to happen? Where is that going to go? I mean, it is a constant process because those conditions can change. And we don't want to put ourselves into a situation where we get stuck or trapped or need help or anything. Like, that's definitely not what we want to do. So this is a really, really big part of these deployments, is trying to figure out how to do this without, getting hurt or putting ourselves at risk. Now, that's what I can do to be prepared for our hurricane work, but what can you do if you live in a hurricane area, or that's something that you need to worry about? What can you do to be prepared for hurricane season? And the first thing you can do is be weather aware. Pay attention to the weather. Know where to get resources or information from trusted resources like NOAA's National Weather Service, NOAA's National Hurricane Center, your local news organizations. They're there to help tell you what the threats are, where it's going to go, how bad it's going to be, all of that information. So know your zone, know where you are, what sort of hazards do I need to worry about? Is it tornadoes or flooding or all of it? Do I need to worry about the winds? What kind of things do I need to have in mind for this kind of thing? And put together an emergency kit. Food, water, medicine, flashlights, first aid. Take stuff for your pets. A lot of people forget that their pets need food or a leash or their medicine, things like that. Like, put all that stuff together ahead of time so you're not scrambling at the last minute trying to get it, and that way you don't forget anything. And have an evacuation plan. Some places will actually ask people to leave if they can because they think the conditions are going to be that bad. So if you do have to leave, know where you're going to go. Don't wait until the last minute. Traffic can get really, really bad in places like this when everybody's trying to leave at the same time. So, definitely don't wait, and make sure that you're prepared for those kinds of things and you've got everything in order ahead of time before you have to do something like that. And don't focus on the exact landfall location. A lot of people try to pick the exact 1 mile area where it's going to make landfall. And hurricanes are massive. They can also be really tiny. So they can affect a pretty wide range of areas. So, where it makes landfall isn't that important. It shifts 5 or 10 miles in either direction. It's probably not going to make a whole lot of difference where you are as to the conditions that you're going to experience. And that wind and that flooding and that tornado threat, that can extend really far away from where that landfall location is. And also, don't pay attention too much to the category. Category 1s are very life-threatening and very dangerous and need to be taken very seriously. So, if it's a category 1 or 2, don't think that that's somehow less important than a category 3 or 4 or 5 or anything like that. We got to take all these things seriously. Now, we've talked about a lot of things today, what hurricanes are, how do we study them, what are some of the tools that we use, how you can be prepared, things like that. It's a pretty complex problem, right? Like, we've got a lot of challenges when we're doing these types of observations, and we got to use a lot of different tools to do it, and a lot of people. Maybe you could grow up someday and be a scientist and come with me and help me study hurricanes and, try to figure out how they work and what all the hazards are and how we can better predict those and better be prepared for those. And this work helps us understand these extreme events. That way they're not as scary. It's something that, we can be aware of ahead of time and be better prepared for them. And there are tons of resources out there. Here's a list of a few of them. I think they're going to put these up on the website, when they load the talk and that sort of thing. There are tons of places that you can get this kind of information from. How to be prepared, where the forecasts are, even fun activities that you can do to kind of learn more about hurricanes and what causes them. And if you guys have any questions, I'm going to take a couple here. I know we probably won't get to them all. So if you have something that we didn't get to or you think is something later, we're going to try to keep track of those. And I'm going to actually go back and answer those, and we'll post them on the website like they mentioned earlier. And you can also follow me on Twitter. I'm usually not very active when it's not during severe weather season or hurricane season, but I post a lot of neat stuff about some of the research that we're doing and, when we're going out in the field and collect these sorts of things. So, occasionally it can be kind of exciting. So with that, I will stop and I will take any questions that you guys have. Thank you.
Thank you so much, Sean. We really appreciated your talk. And we have many questions. So, all right, let's see here. So we had the question earlier. Liam had asked, what was the fastest hurricane growth that you tracked?
Yeah, and I was going to mention that in my talk, and then I got off onto something else. So the highest wind speed that I have personally experienced inside of one of our hurricane deployments was about 120 miles an hour. And that sounds really, really fast, and that's because it is. But when we're in those situations with the vehicle that we have, and this kind of ties into one of the other questions we got about how do we, protect ourselves, we can actually turn that vehicle so that we're still facing into the wind. And at that point, it's kind of like driving really fast down the interstate. You know, there's pretty strong winds if you're driving down the interstate at a high rate of speed. So it can be really, really windy, but we have ways of kind of protecting ourselves to make sure that we're not, you know, in danger. And I'll tell you, raindrops hurt at 100 miles an hour. Standing outside in that is not fun.
All right, thank you. We have actually both Jasper and Nancy asked, how do you collect the instruments after the storm? For example, the weather balloons.
Great question. So those weather balloons actually transmit their data on a radio in real time. So as soon as we let it go, we start getting that information back. And sometimes they go really, really far away, and sometimes they don't go that far away at all, but they're meant to be disposable. We can't use them again once we get them back. So we actually don't go out and collect them. And in a lot of these cases, I don't know if we'd even be able to find them. We track them on the way up, but once that balloon pops and the instrument comes back down to the ground, we actually don't always know where it goes. And you can actually go out and find some of these things on occasion. There are people that will just walk out in their backyard someday and see one laying out there. And, you know, a lot of times we'll have like a sticker that says what it was and where it was from and that sort of thing. And if you find it, there's usually a mailing address on it, and you can actually mail it back. And it's kind of neat to see where they end up sometimes, depending on where you launch them. But we actually don't go get them back.
Wow, that's amazing to just lose the instruments sometimes.
Yeah.
How far ahead can you predict a hurricane before it makes landfall? Mark asked this.
So that is a really good question. And this is what NOAA's National Hurricane Center does, and they do so well. They start tracking those systems before they're even a hurricane. You know, they might just be a small collection of storms. And it kind of depends on where they form. I mean, Hurricane Sam, which is going on in the Atlantic right now, has been out there for like weeks, it seems like. I think it's been out there for like a week and a half, or almost 2 weeks. And it's not really affecting anything. It's just kind of meandering around in the ocean. But I've seen systems that we've deployed on where we've had a week's notice beforehand. But our decision to deploy is based on where we think it's going to go, and, you know, what else we have going on, and can we get there and set up, and is everything in the right order? Like, there's a lot of other, you know, things that go into our decision about whether we operate on these or not. But the Hurricane Center does a great job at forecasting those days in advance, and there's always plenty of warning for those types of systems.
Great. And actually, we had a request. Sean, would you mind just maximizing your face so we can see you better? Thank you so much. And then we had a couple other questions. We have some safety questions actually, which are really good. Michelle asked, is it important to know where the shelters are?
Absolutely. Shelters are one of those things, and we talked about that during our severe weather talk last year. You know, you might feel like sheltering in your house, you know, it's where you know and you're comfortable, but there are shelters in a lot of these areas that are specifically designed to try to handle these conditions. So if there is a shelter, know where it is, you know when you need to go there. Don't wait until the last minute to go, that sort of thing. These are great tools and great pieces of information to have. So yeah, definitely pay attention to where those shelters are.
Okay, great. And then actually, Theodore had also asked another really good safety question. Well, and he says, this isn't hurricane related, but how long is it safe to watch a storm coming in?
So that's a really good question. And you know, growing up, I did that a lot, right? I'd stand at the window and, you know, watch it lightning outside, and I was always fascinated by it. And there are, you know, situations there where that may not be the best idea. You know, we tell people during a tornado, for example, we don't want you taking shelter near a window because that window could break and that glass could fly inward, and that can cause problems. So when there is a severe storm, or, you know, a tornadic storm or a hurricane or something like that, there are safety steps that, you know, we try to tell people to take. Like if it's lightning, go inside. You know, if it's flooding, obviously turn around, don't drive through it or walk through it, things like that. And that's to try to keep you guys protected, because we don't want anybody to get hurt from these types of events. So as tempting as it might be to, stand on your front porch and kind of watch the storm roll in, when it starts getting close enough that, you might be in danger of having, be struck by lightning or get hit by hail or some of those strong winds, like definitely go inside and take shelter, because it's just not worth the risk.
Fantastic. Well, let's see. We've got maybe one more question. Let's see. Let me see. We have Paul had asked, have you ever had a NOAA building collapse in a storm?
Ooh, I don't think so. I don't know the history of every building in NOAA or anything like that, but I am not aware of any building like that collapsing, thankfully.
That's great. And I wanted to ask one more question, then we'll be done. So this is a good question. Paul asked, do you ever travel up to space to track storms?
Up to space?
Yes.
Well, that would be really exciting. And going to space as an astronaut is probably one of my other childhood dreams. I've never done it. And that I am aware of, that is not something that I study, but we don't send people up to space to study things. But what we do, well, at least weather related, I should say. But what we do send up to space are satellites. And those satellites are very, very powerful tools. They give us a look down at what the atmosphere is doing and give us a lot of information in places that we can't reach. So in a way, we do use space to study these types of storms all over the world. When it's out over the open ocean or when it's out over land, like those satellites can be very, very useful. And there may be experiments that have been done in space on weather on the Earth. I just don't know. I'm not an astronaut, and I don't study those kinds of things. But that's a really great question.
Sure, yeah. Well, we've got all sorts of great questions here, but unfortunately, I think we're running out of time. So I'm going to say thank you so much, Sean, for your amazing talk. And I think we all learned a lot, and we can share our new knowledge with friends and family. And as we said earlier, we will absolutely try to answer your questions, and we can post the answers on our website. So stay tuned for those answers. And you'll also have resources that you can use to look up to try to find the answer yourself. So please stay tuned for a post-webinar survey because we would love your feedback. And for information on past and upcoming webinars, or to receive a NOAA Live Iron-On patch, visit our website at Woods Hole Sea Grant. And we look forward to seeing you at our next webinar on October 19th. Thank you so much, everyone. Have a lovely day.
Thanks, guys.